Okay. We're going to pick back up in our substitution right now is what we're going to do.
Substitution.
So,
Let's go. Yeah.
What do we remember from substitution? What was, on Friday, what was the first thing we have to look for?
I know.
What is it, Aaron?
You need to see if there's an equation that has x equals or y equals.
Okay. So we want one equation to either be x equals or y equals. As we move into this one, what do you notice?
There's no x or y.
Yeah. The two examples we did on Friday, there was a y equals, there was an x equals. Now we have a situation where we don't have the x equals or y equals. Gatlin, what are you going to tell me to do here?
You minus the 2y on the -4, and then you get x equals. Yeah.
Okay, so officially, you can pick whichever equation you want to here to make x equals or y equals. Now, I think most of us will agree, in this case, the top one is easier to maneuver. In order to get x by itself, we can move the 2y away, which means we are going to subtract 2y. So x equals, and I don't know, for this purpose, we could leave this as -4 minus 2y. If you prefer to say -2y minus 4, you can do that as well. Your choice. And then, every place we see an x in our other equation, we're going to replace it with
Y. That equation right there.
-4 minus 2y. So we're going to go 3 times x, except what is x?
-4 minus 2y.
-4 minus 2y. So there's my 3 times x. It's still going to be minus y equals -5. And that's the main difference between this one and what we were doing on Friday. First step, we're still going to
Distribute.
Okay. We're going to take the 3 and distribute. 3 times -4, -12. 3 times minus 2y,
-6y.
minus 6y, still minus y, and still equals -5.
Combine my terms.
Okay. Look to solve it. Since I have 2 y's on the left, we can combine like terms, so I'm still going to have -12. What is -6y minus y?
-7.
Yeah. Remember, there is an invisible 1 here, yes? And -6 minus 1 is -7y. Still equals -5. We want to get y by itself. So to get the -7y term by itself,
Add 12.
we're going to move the -12. To move the -12, we are going to add 12. -12 plus 12 cancel, leave me with -7y. -5 plus 12 is 7. And then we all know, if it's -7y, to get y by itself, divide by -7. And what is 7 divided by -7?
-1.
But we're not done.
Okay. Y equals -1. And he's not even going to let me ask my question, are we done?
No, we're not done.
Okay. Why am I not done?
Because you got to plug y in back in one of the equations. What? X.
Okay.
No.
Remember, our answer is an ordered pair. So what I know about my answer right now is I know y is -1, so I know my answer is something comma -1. That's what I know at this exact moment. In order to find the other piece, take -1 and plug it back in. We always say one of the two originals, or if we have an equation we solve for x equals or y equals, I like to use that one.
Yeah, me too.
So I would plug it in up here, say x equals -4 minus 2 times -1. Remember to multiply before you add or subtract. So negative 2 times negative 1,
It's 2.
it's going to become plus 2. Negative 4 plus 2,
Yes. 2, negative 2.
negative 2.
Yep.
So we have a solution,
Negative 2.
negative 2, comma negative 1. Okay. Hopefully substitution's coming back to you a little bit. That's my hope there. And hopefully this little, the extra little step we added makes sense there. One more substitution before we move on to elimination. If I'm looking at substitute, do I have an equation that is x equals or y equals?
Nope.
I don't, do I? Okay. Options. And different people may do different ones on this, different things on this one. I don't know. What are you going to say, Gatlin?
You divide it all by 2, and then like you multiply it by 2 at the end, but like you divide it by 2, and then that would be
Okay.
2 or y equals 6
I'm
or
lost.
3x minus 1.
Okay, so you're saying take the second equation
Yeah.
and try and get it to be y equals, is what he's saying.
Yeah.
Because this is 2y, it's already partially y equals. It's the y term equals. So since it's 2y equals, and these are going to divide nicely by 2, aren't they? I tend to kind of look ahead. Do I want to divide by 2? Is this going to make nice numbers, or am I going to make life miserable for myself?
I remember doing that.
Okay, so I'm going to divide everybody by 2 in that second equation. By dividing everyone by 2, it becomes y equals 3x minus 1. Every place I see a
Why?
y, we're going to replace it in the other equation. So my other equation is negative 6x plus 2 times what?
3x minus 1.
Y, which is 3x minus 1, and it equals 8. Okay? Are you doing the math?
I am.
Got negative 6x. Distribute the 2. So then I'm going to have plus 6x minus 2 equals 8.
Combine like terms.
Okay, if we combine like terms, what is negative 6x plus 6x?
I don't know.
Okay, I can't say x,
I think it's
because if I say x, what number do you automatically put in
1.
front of an x? A 1. Is this 1x?
no.
No.
0.
Now, we can say 0x if we want, although in all honesty, I don't even say 0x. I usually just, it's 0. You could also think it's gone. It's nothing. Okay? Now, if I put a 0 there just for the looks, we still have minus 2 equals 8. Well, what is 0 minus 2?
Negative 2.
Equals 8.
Divided by what?
So what's the problem?
There's no x or y equals. You don't
Okay.
solve it.
So right here,
There's no answer.
my x is canceled. When those x's canceled, that started me off, assuming I haven't made mistakes, of saying it's not going to be a traditional ordered pair. It's going to be one of two things. There's either no solution whatsoever, there is no ordered pair that could possibly work, these lines will never cross, never touch, meaning they are parallel. Or the other option is there are infinitely many solutions where basically the lines are the same and they're always touching. Now, in this situation, how do I tell if this is no solution as opposed to infinitely many solutions, which is kind of like saying all real numbers in a way, but infinitely many solutions?
Oh, I know.
What do you think? Does negative 2 equal 8?
No.
Right?
No.
That matters right here. Negative 2 does not equal 8 in any way, shape, or form, so what's that lead you to believe?
There's no solutions.
there's no solution.
Yes, sir.
The other option, if this had come up, 8 equals 8, -2 equals -2, 0 equals 0. If it had come up with a true statement in the end, like once your variables cancel out, if you come up with a true statement, then it's infinitely many solutions. Since my variables canceled out and I got a very false statement, that's what made it no solution. Okay? Watch out for those. They pop up every so often.
Okay, yeah. B.
Okay. So we graphed on Friday. We kind of reviewed substitution here. And now we need to
Eliminate.
eliminate.
I think this is faster. Actually,
Now, as we work to eliminate, different people have different preferences, which they prefer, elimination versus substitution. For me, honestly, it depends on the setup. Okay, the ones we're getting ready to see are probably a little more set up for elimination because do I have an x equals or y equals here? No, and I don't have, we can make one of those x equals or y equals, but neither of them are ideal. We end up with fractions. It's just, it's not ideal. So, the idea of elimination is we're trying to eliminate the variable, eliminate one of the variables by adding our two equations together. Now, sometimes it requires a step or two before we can actually add them and eliminate something. Or sometimes it's like this one where we're ready to eliminate right off the bat. Which variable am I ready to eliminate if I add these two equations together? Yeah, notice, so I'm not even going to rewrite it. I'm going to use it right here. First of all, 4x and -4x. It's important to note that they have the same number in front of them, yes? Anytime you see 4x, whether it be positive 4x and positive 4x or positive 4x and -4x, that's where you want to start with your elimination. Now, what's ideal is I always look for them to have opposite signs. Because when I add a positive 4 and a -4, then it's going to cancel out when we add them. So as long as they have opposite signs, we can just add. So, what is 4x plus -4x?
0.
0. It's gone. I don't even need to write it. Okay? Move to the next column. What is 2y plus 3y?
5y.
Carry down your equal sign. And notice all my pieces are added up, yes? What is 9 plus 16?
25.
25. 5. Y equals 5.
Gosh.
You're ready to solve here?
Yeah.
Elimination, and this one's going to be kind of reversed. Substitution took a little longer at the beginning, was easier at the end. This one's probably going to be reversed. It's a little quicker at the beginning, maybe takes a little longer at the end, but if we're going to solve this, 5y equals 25, so we're going to divide by 5. When we divide by 5, 25 divided by 5 is 5. Are we done?
No. No.
No.
Gotta plug it in.
Not done. Remember, all answers, unless it's a special case of no solution or infinitely many, all my answers are ordered pairs. So, I know y is 5. Like if I stop right now, that's what I know about my answer. It's something, comma, 5.
That's it.
So, how do I find x?
Plug it in.
Okay. We're going to take that y equals 5. We're going to plug it in to
Top one.
one of your original equations, right? You guys are picking top one because there's no negative, right?
Yeah.
I don't blame you. You can pick either, technically. So if you're like, bottom one looks better to me, take that route and meet me at the end. So if I use the top one here, 4x plus 2y, so 2 times 5, equals 9. 4x plus 2 times 5 is 10, equals 9. If it's 4x plus 10,
minus 10.
We're going to subtract 10. 9 minus 10 is negative 1. If it's 4x, how do I get x by itself?
Divide.
Divide by 4. It is going to be a fraction, but you know what? Does it matter at the end?
No, we're not graphing it.
We're not having to graph it. We're not doing anything with it. It's just our answer. So this is a great place to have a fraction. I don't have to work with it. So negative 1 divided by 4? Negative 1/4 is a perfect answer to me. And so that gives me my x value of negative 1/4. So final answer, negative 1/4, comma 5. Okay. I would accept the decimal equivalency of negative 2500ths, negative 0.25. The online homework? Read the directions, right?
You never know with them.
Exactly. You know, it's just, you know, it does still have that math Excel side to it. I can't guarantee what they're going to want in their answer. So watch carefully, right? And I can't say when I was picking out problems last night that I paid attention to what they wanted. So. Does this ring a few bells? Maybe?
I think I'm getting her done.
I'm hopeful. Okay. Well, let's look at the second one. Negative 2x plus 8y equals negative 8. Negative 5x plus 8y equals negative 20. Which variable are you guessing we're going to eliminate?
8. But they don't have opposites.
The y's, correct? Okay. So because the y's have the same pieces here, that would be my recommendation. Now, what's different about this problem?
The same
There's
sign.
no, you don't get a y.
They're the same sign.
Well, I have the same sign, right? So if I add 8y and 8y, are they going to cancel?
No.
No.
Oh.
So we have two routes we can go with this. I used to teach that you then, if they're the same sign, you subtract.
What?
And so one option is we could say we're going to subtract these two equations. Now, that's not the route I'm actually going to go because we tend to goof up all of our negatives when we do that. Because we get goofed up and we have to do negative 2 minus negative 5, and we forget to actually subtract. So the other route I teach is you pick one of these equations and multiply one of them by negative 1. And then we will have a negative, won't we?
Yes.
Now, does it matter which equation you multiply by negative 1? No. But if you want a sign to change, I'm going to use the bottom one. I'm going to multiply by negative 1. So I'm just going to carry my top equation over here. It's going to stay the same. Negative 2x plus 8y equals negative 8. My bottom equation. What happens when you multiply everything by negative 1?
All the positives become negative on the negative positive.
Okay. All your signs change, right?
Yeah.
So it's going to become positive 5x minus 8y equals positive 20.
Right. You can do that.
And now we are set up to add. So add your like pieces. Negative 2x plus 5x is 3x. 8y plus negative 8y? 0. They cancel. I don't even write anything down. Negative 8 plus 20.
12.
12.
Wow.
Now, if anyone is sitting out there and said, you know what, I like the idea of subtracting better, and you tried subtracting, here's the thing. Because I multiplied the bottom row by negative, you're getting the same thing. If you had subtracted, you'd be at the exact same place right now. So, in case anyone's interested there. Okay, what happens when we solve this? Divide by 3, and x is 4. And? Yeah, don't even have to ask it. I'm not done.
No, don't even.
What are we going to do with this 4?
You're going to plug it back in.
And where do I want to plug it back in?
Wherever you feel like.
Okay.
No. I like the top.
Top or bottom?
Top.
You have to deal with negatives this time. Let me guess, the top has smaller numbers, right? Again, it doesn't have to be the top one, you pick. So if I use negative 2x, but x is 4, plus 8y equals negative 8.
Whoa.
Negative 8 plus 8y equals negative 8. Man, there's a lot of 8's here. How do I get the y term by itself? If it's negative 8, we're going to add 8 to move it over. Negative 8 plus 8 will cancel. 8y equals, what is negative 8 plus 8?
0.
0. Do I stop here and say no solution?
Nope.
I asked that because that's what some of you will do. Oh, there's a 0, no solution. No, we'll keep going. How do we solve for y? Divide by 8. 8's cancel. Y equals, what's 0 divided by anything?
0.
0. If I have 0 cookies and I'm splitting them amongst 8 friends, each friend is getting
0 cookies.
0 cookies.
That's a good way.
Okay? So, my ordered pair is 4, 0.
And your homework you change. You just have 0 cookies.
Well, it's a whole different story if you have 8 cookies and you're trying to divide them amongst 0 people. That doesn't really work. You have to include yourself at least and divide by 1. Because that's when we say, we don't divide by 0. Okay. Good? This is technically review. Technically. I'm not assuming you guys remember it, though. Okay, now I'm going to go to the next screen. I'm going to readjust here because I want... Maybe I don't want to readjust this. Okay. Okay, what do we notice in the next? 2x and 3x are not the same. 7y and 5y are not the same. Okay, so this is where you've got to start thinking to yourself, because I still want to teach elimination, because I'll be honest, I don't really want to do substitution with this one.
You multiply.
I've tried.
So,
You multiply by whatever their common.
You just multiply the top one by 3 and the bottom one by 2 and
Yeah.
the same.
Because both make it 6.
So, yeah, think in terms of, we either want to make the x's the same, and so I think what Galen's trying to use the word least, whatever, we're trying to go for a least common multiple.
Yeah, that's what it
So we
was.
can either look for, and I know some of you are saying, don't throw that word in. I'll explain it, but we can either try and make 2 and 3 the same. So what, if we were getting a common denominator between 2 and 3, what would be the common denominator? Or we can make 5 and 7 the same. If we're getting a common denominator between 5 and 7,
35.
we'd be going for 35. I'm guessing most of us are going to say, 6 sounds
35.
better, it's smaller, right?
Yes.
So, now, what that means, if this is a 2x, what do I multiply 2x by?
3.
3. Now, if my bottom one is a 3x, what do I multiply it by?
2.
Oh.
Negative 2.
Why is negative 2 going to be helpful?
Because it makes your x a negative, so they cancel.
Right. So, and it doesn't matter. We could have used a negative on the top equation. But when we do this, if both numbers are positive or the same sign, multiply one of them by a negative. Doesn't matter which. So let me write this out. When I multiply the top one by 3, my equation becomes 6x plus 21y equals 12. My bottom equation becomes negative 6x minus 10y equals positive 10. (6x) and negative 6x worked out to be opposite signs. So we're adding them, yes?
Yes.
6x and negative 6x are gone, right? They're 0, they cancel. 21y plus negative 10y. 11y. Carry down your equal sign. 12 plus 10. 12 plus 10 is 22.
2.
The obvious step of solving here, right?
Divide.
If it's 11y equals 22, divide by 11. And y is 2.
So when you plug y back in, do you plug it into the one where you multiplied, or do you plug it into the base?
You multiply.
So, the question, where do we plug the 2 back in?
The multiply. After you multiply, before after.
I personally would go back to the original
Oh.
Yeah.
and use it before. Now, could you use the multiplied one?
Yeah.
Yes, you can. But you had a little bit bigger numbers there by the time you got multiplying, didn't you? So I would pick one of the originals. And I'm going to pick the bottom one just because we haven't used the bottom one. Okay? We've been using the top on the others. So if I use my bottom one here, 3x plus 5 times y, which is 2, equals negative 5. 3x plus 5 times 2 is 10. I even threw in a negative at you. If it's 3x plus 10, I'm going to subtract 10. Negative 5 minus 10, negative 15. Divide by 3, and x is negative 5. Final answer? Negative 5, comma 2. Okay. 2 more. One more big one, one more small one. 3x plus 7y equals 15. 5x plus 2y equals negative 4. I don't really want to substitute because I don't want to solve either of those for x equals or y equals. Neither of them look fun in that case. So I want to eliminate the way they're set up. They're in that standard form. Do you want to eliminate x's or y's?
Y. It's 14.
So we could go for 14 y's or we could go for 15 x's. Doesn't matter. Okay?
I actually do.
You could do either or here. I honestly, I'm going to do y's just because last time we did x's. I don't want the y's to feel left out. Now, here's the deal. If you're confident what you're doing, can you go your way and meet me in the end? You can. And you should get the same answer. Okay? So I'm going to choose y's. And as I choose y's, what am I going to have to multiply 7y by?
2.
2. What am I going to have to multiply 2y by?
7.
Negative.
Negative 7.
Okay. So I'm going to use 2 and negative 7. If you're doing x's, you used 5 and probably negative 3. Again, there's not one right way to do this. Now, if you're not confident, though, definitely stay with me, right? Top one, multiplying it by 2. Six x plus 14y equals 30. In the bottom, we multiply by negative 7. Negative 35x minus 14y equals 28. And we are ready to what? Add. We're ready to add because y's are the same. There, I promise. Okay, guys. 6x plus negative 35x. Negative 29x. 14y plus negative 14y. There's the 0 we wanted. Carry your equal sign down. 30 plus 28. 58. Looks a little scary, but does it work?
Yes.
Yeah. Negative 29x, divide by negative 29. And x is what? Negative 2. Am I done? Not done? Because? Yeah, plug it back in. Which one did you guys plug back into?
The bottom one.
Bottom one has smaller numbers but has a negative, doesn't it?
Yeah.
Top one has bigger numbers but all positive. Again, it's your choice, isn't it? Go with what you are comfortable with. I'll go with the bottom. 5 times negative 2 plus 2y, whoops, equals negative 4. I'm running out of room. Negative 10 plus 2y equals negative 4. What to do next to solve for y? Add 10. Negative 4 plus 10 makes it 6. Divide by 2, and y is 3.
Damn, I did that.
How are you expressing your final answer?
Negative 2,
Negative 2, 3. Did anyone venture out on their own? Did you match me in the end?
Yeah.
Okay.
I did total opposite of what you did.
So you eliminated the x's instead of the y's.
Mm-hmm.
And that's fine, right?
And I put it
So.
back into the top equation.
Okay. One more example. And if you've looked at this one,
Infinite solutions.
you either know what you're doing or you're really, really confused by this one, right? Depending on the situation. Notice, what do you want to eliminate if I go that direction with you?
Everything eliminated.
Okay. You could say eliminate x, you could say eliminate y, but they're both set up to eliminate. So, okay, let me show. Negative 3x plus 3x is 0. Y plus negative y is 0. So that whole side is 0. Carry your equal sign down. Negative 5 plus 5.
0.
0. Okay. Think back to what I said on substitution on the front side. My variables did what? They canceled. So when the variables cancel out, I say you have 2 options. No solution or infinitely many solutions. What's your thoughts on this one? Why is it infinitely many? 0 does equal 0. Like the front side, if we'd gotten a false statement such as 0 equals 10, then we'd say no solution. Because my variables cancel out, I got a true statement. We're going to say infinitely many solutions. Okay.
Well, we got homework time.
You got a little bit of homework time. I got you 8 minutes. So it is in Savas. I'm not sure you can do 8 of these, but it's going to say lesson 1.6, part 1.
Dude, if we were in the project class, I would not be
And she gets so mad.